compressors used in refrigeration systems can be classified in several ways. A. Based on the working principle. 1. Positive displacement type. 2. Rotor dynamic type. In positive displacement type compressors, compression is achieved by trapping a refrigerant vapor into an enclosed space and then reducing its volume. Since a fixed amount of refrigerant is trapped each time, its pressure rises as its volume is reduced. When the pressure rises to a level that is slightly higher than the condensing pressure, then it is expelled from the enclosed space and a fresh charge of low-pressure refrigerant is drawn in and the cycle continues. Since the flow of refrigerant to the compressor is not steady, the positive displacement type compressor is a pulsating flow device. However, since the operating speeds are normally very high, the flow appears to be almost steady on macroscopic time scale. Since the flow is pulsating on a microscopic time scale, positive displacement type compressors are prone to high wear, vibration and noise level. Depending upon the construction, positive displacement type compressors used in refrigeration and air conditioning can be classified into 1. Reciprocating type. 2. Rotary type with sliding vanes, rolling piston type or multiple vane type. 3. Rotary screw type, single screw or twin screw type. 4. Orbital compressors, and 5. Acoustic compressors. In rotodynamic compressors, the pressure rise of refrigerant is achieved by imparting kinetic energy to a steadily flowing stream of refrigerant by a rotating mechanical element and then converting into pressure as the refrigerant flows through a diverging passage. Unlike positive displacement type, the rotodynamic type compressors are steady flow devices, hence are subjected to less wear and vibration. Depending upon the construction, rotodynamic type compressors can be classified into 1. Radial flow type, or 2. Axial flow type. Centrifugal compressors, also known as turbo compressors, are radial flow type, rotodynamic compressors. These compressors are widely used in large capacity refrigeration and air conditioning systems. Axial flow compressors are normally used in gas liquefaction applications. Based on arrangement of compressor motor or external drive. 1. Open type. 2. Hermetic, or sealed, type. 3. Semi-hermetic, or semi-sealed, type. In open-type compressors, the rotating shaft of the compressor extends through a seal in the crankcase for an external drive. The external drive may be an electrical motor or an engine, for example diesel engine. The compressor may be belt-driven or gear-driven. Open-type compressors are normally used in medium to large capacity refrigeration system for all refrigerants and for ammonia, due to its incompatibility with hermetic motor materials. Open-type compressors are characterized by high efficiency, flexibility, better compressor cooling and serviceability. However, since the shaft has to extend through the seal, refrigerant leakage from the system cannot be eliminated completely. Hence refrigeration systems using open-type compressors require a refrigerant reservoir to take care of the refrigerant leakage for some time, and then regular maintenance for charging the system with refrigerant, changing of seals, gaskets etc. In hermetic compressors, the motor and the compressor are enclosed in the same housing to prevent refrigerant leakage. The housing has welded connections for refrigerant inlet and outlet and for power input socket. As a result of this, there is virtually no possibility of refrigerant leakage from the compressor. All motors reject a part of the power supplied to it due to eddy currents and friction, that is, inefficiencies. Similarly, the compressor also gets heated up due to friction and also due to temperature rise of the vapor during compression. In open type, both the compressor and the motor normally reject heat to the surrounding air for efficient operation. In hermetic compressors, heat cannot be rejected to the surrounding air since both are enclosed in a shell. Hence, The cold suction gas is made to flow over the motor and the compressor before entering the compressor. This keeps the motor cool. The motor winding is in direct contact with the refrigerant, hence only those refrigerants, which have high dielectric strength, can be used in hermetic compressors. The cooling rate depends upon the flow rate of the refrigerant, its temperature and the thermal properties of the refrigerant. If flow rate is not sufficient or if the temperature is not low enough, the insulation on the winding of the motor can burn out and short-circuiting may occur. Hence, hermetically sealed compressors give satisfactory and safe performance over a very narrow range of design temperature and should not be used for off-design conditions.